In this class we're going to look at purposive and Snowball sampling and have some wider comments on sampling in general. So to start, we'll look at the elements of selection. So first of all, we're talking about sampling, and we're trying to derive a sample from the population. And the idea of sampling is to save on costs. To sample the whole population, which we call a census, and I'll mention it again in a second, but if we sample the whole population, we call that a census. Sometimes that can be very expensive. Depends on the size of the sample and how easy it is to sample them, but sampling as a method is much cheaper. But the issue here is to try and make sure that the results of the sample, calculated from the sample, are representative of the population. They may not be because of bias and because of issues involved in sampling. So the first big term we come across here is sampling. What is sampling and how is a sample selected? Second, we have the population elements. What is the population? The population could be people. It could be customers for a particular product. But the sample could also be some physical issues. A sample of rocks for a geologist. That could be the sample. For sociologists, it could be people living under particular circumstances. For economists, it could be a sample of consumers or a sample of voters who have opinions about government economic policy. So it depends on the population element. What is it we are trying to calculate? What is the population element? What are the characteristics of the population element? And what is the population itself? What is the size of the population? How is the population distributed? What are the characteristics of the population? And as I said earlier, if everyone in the population is sampled or looked at, then it's a census. It's not really a sample anymore because everyone in the population is considered. That's called a census. Now let's look at the attributes of a good sample. Well, first of all, it should be accurate. In other words, the results of the sample, when they're calculated, let's say the average of the sample, should correspond to the average of the population. Generally speaking, we don't have confidence enough to say that one is precisely the same as the other. Generally speaking, we say that the average of the sample is the same as the population, plus or minus some margin of error, plus or minus some factor, some percentages, let's say. But it should be accurate. It should be close to the population figure. So it should be accurate. And the bigger the sample and the more, if you like, scientific the sample was selected, the better it was selected, the more precise the estimate will be. The better the estimate of, let's say, the average or of the standard deviation or whatever it is we're working out, the more precise that will be to the population. Ideally, we'd like to say that the average calculated from the sample is exactly the same as that of the population. But we can only do that if we have a census, if we take everybody in the population into account. As long as we're leaving some people out, or some elements of the population out, if it's not people, then we can't be that precise. We can't say for definite that the results of the sample correspond exactly to what would happen in the population. So we have some margin of error, but it should be fairly precise. Now the types of sampling design, well, we have probability sampling, which we would call random sampling. A random sample is when every element in the sample has an equal, every element in the population, I should say, has an equal probability of being selected for the sample. So if we're talking about customers for a particular product, we'd need to know all the customers for that particular product, and then we'd need to have a list of their names. We would give a number to each one of them, and we would draw out a number and select that person on the basis of a raffle or of a draw. And in that way, everyone in the population had an equal chance of selection. That would be probability sampling. That's random sampling. But we also have non-probability sampling, which is convenient. It's cheap. It's quick. Unfortunately, it may be very biased and the results may be very inaccurate, but it's often used. Now, the steps in sampling design. Well, the first question to ask is, what is the relevant population? What is the population? Because if we don't know what the relevant population is, we can't sample from it. So that's the most basic question. And what are the parameters of interest? What are we if we know that we're looking at the population are customers for a certain product, then what are the parameters we're interested in? Are we looking at all the customers for that particular product, or just the customers who live in a particular city? Maybe that's the parameter. We're just looking at customers for a particular product who live in a particular city, or customers for that particular product who have certain income levels, or who work in certain occupations. So we have refined the sampling exercise. We have refined the selection procedure. So what is the sampling frame? What are we drawing from? What sort of sample is it? What's the type of sample? Are we drawing randomly? Are we drawing non-randomly? Are we drawing from, let's say, the customers for a particular product, all of the customers? Do we have information about all of the customers? Are they in a particular location? Have they got a particular income level? What's the size of the sample? How many do we need to sample? And so we need to address these questions. What's the size of the sample? And also, how much will it cost, the whole exercise? Will the information that's yielded from this exercise justify the expense? It may be quite silly just to perform a survey for a survey's sake. The survey should yield some results that are useful. So, is it cost effective? Now, some concepts that we bump into. First of all, the standard error of the mean. If you like, what is the deviation from the mean? And it depends on the degree of confidence that we want. If we want to say that the random sample has a mean of a certain amount, and this corresponds to the population mean, and we're 95% confident, in which case we will work out the standard error and add this on to the sample mean to give us an interval. And in that interval, the population mean should rest. And we're 95% or we're 99% or we're 68% or whatever it is, percent confident that the population mean rests in that interval. The probability sampling designs. Well, we have a simple random sample where we just select from the population, and every member of the population has an equal chance of selection. We have systematic, where we sample from the population, where we sample under certain characteristics. So we might be just looking for female consumers of a certain product, or we might be looking at consumers over a certain age for a certain product. And we might be doing this systematic by taking every 4th customer or every 10th customer. So it's systematic. Stratified is where we're just looking at the different layers, the different strata in society, male, female, certain age groups. And we're trying to make up a representative sample to ensure that all the different strata are included. Male, female, different age groups, people living in different areas. These are all different strata. And the systematic one, where you're picking the first one randomly and you're picking every 10th customer after that. Or you pick a street and you pick the street randomly and you interview the people living on that street and you pick every 4th house. That's systematic. Unfortunately, it could lead to bias because the characteristics of that street may be atypical. They may not be representative of the population. Just bad luck. Under stratified, we'd have clusters. We could have, say, clusters of customers in a certain area. Or we may have clusters, a lot of customers in one area are of a certain age, and in a different area they're a different age again. We could have quota sampling. We might want to have the researcher assign some proportion to be looked at from each strata. So let's take 50% male, 50% female. Well, that might be wrong. It depends on the nature of the product. If it's a certain cosmetic product that's mostly used by ladies living in a particular area, then 50-50 male-female may not be representative. So quota sampling has got problems. Now let's look at the cluster samples. Well, for a start, how homogeneous, how similar are the clusters? If we have a cluster of purchasers of a particular product living in a particular area, does that mean that the characteristics of one of the customers is representative of all of the customers in that area? Maybe not. So it depends. So assuming that there's a cluster and simply picking up on the cluster doesn't mean that the information is precise. There may be a high degree of heterogeneity in the cluster, a lot of differences in the cluster. It just so happens a lot of people who buy the product live in a particular area. We also have equal and unequal clusters. So sometimes we get a cluster in one area, we get a large number of buyers, let's say, in one area, and we get a large number of buyers in a different area, but they're not equal. So we can't say that the clusters are the same, or they share the same characteristics. There may be different reasons as to why there are clusters in different areas, different combinations of purchasers or buyers in different areas. So samples drawn on that basis may be not correct. And how large should the cluster be? If there is a cluster, how big should it be before it constitutes a cluster? If we're saying that there's a large cluster of purchasers in a given area for a particular product, and if we interview 10 of them, these are going to be representative of that cluster. And that's not necessarily the case. How many do we need to interview to figure out why there is a cluster in that area. So that's an issue. How large should the sample be? And that's always a problem. Statistics can make some recommendations depending on how precise we want the information to be and so on, but there's still an issue. How big should the sample be? And by and large in business, a lot of that is determined by the budget available for the research. Non-probability sampling is quite difficult, and it's difficult to almost justify it. It's essentially non-probability procedures. They have to try and meet the sampling objectives. So the non-probability procedures have to look at what the sampling objectives are, and if the sampling objectives enable non-probability procedures to be used, then fine, that's okay. But the non-probability procedures tend to be prone to bias, to selection problems. And we'll talk about this in a few moments again, but for the moment, non-probability procedures tend to be biased, and therefore the results are more suspect. So we're talking about the sampling objectives, what the objectives are, and whether non-probability procedures are satisfactory. But non-probability procedures do have an advantage because they are very cheap. It's just simply finding a number of people to answer the questionnaire, or to get involved in a focus group, or to get involved with some interviews. It's cheap. It's easy to select. And in the case where there is limited time, this is quite good. But there's a trade-off here, a trade-off between convenience on the one hand and accuracy on the other. And although it's cheap, it may lead to very misleading results, and that's a problem. There's not as much human error as selecting a completely random sample. Selecting a completely random sample may involve quite a lot of human error as well, because let's say we wanted to find population, the feelings in the population about government economic policy. Now that's in the population. So we first of all need the names and addresses of everybody in the population in the country. We would then need to sample them scientifically. We'd have to assign a number and try and draw out numbers randomly. We'd have to determine the size of the random sample we needed. Then we'd have to book appointments with these people, and then we'd have to travel all over the country to try and interview them, only to find when we get there perhaps they've nipped out for some shopping or have gone on holiday. So sometimes, because of non-responses, there are errors involved in completely random sampling. Whereas with convenience sampling, with non-probability sampling, there's a better chance of hitting the target. If you wanted to interview 100 and it's non-probability, just find 100 people to answer it. As I said, unfortunately, this may lead to very distorted results. But on the other hand, completely random sampling the whole population could lead to erroneous results as well, because of non-responses or because of inaccuracies of all sorts that may creep in the random sampling process. I suppose the outcome of all of this discussion is that there is no panacea. There's no way that sampling can be conducted with any certainty, any absolute certainty. With non-probability sampling, the total list of the population is not needed. With non-probability sampling, it just means finding people to answer the questions or get engaged in the process. With random sampling, we'd need a list of everyone, and that may not be available. So random sampling is complicated, and random sampling sometimes can lead to erroneous results because of non-responses, the fact that the total population is not known, because of the costs involved in conducting it. Now, non-probability sampling designs, well, there's convenience sampling. I've been suggesting this earlier. Convenience is ask your next door neighbour, ask your friend in the office. It's convenient, but it's very biased. And there's purposive sampling, where people are trying to find information related to a certain issue and find it efficiently and quickly. Again, very biased. And snowball sampling, where they're using recommendations. You ask your friends, and then you ask your friends to make recommendations to their friends, so they recommend you, so you can go and ask them. And then you ask them for recommendations to their friends, and they recommend you, and you can go and ask them. It's snowballing. But again, it's biased. It's biased because you may be asking a lot of people of the same opinion. They're all members of the same political party, they're all members of the same club, they all live in the same area, they all work in the same company, or whatever. It may be very biased. So the snowball sampling may be of that nature. Let's look at these in a little bit more detail. Let's look at purposive sampling. This is used when you want to access a particular subset of the population. When taking the sample, reject people who do not fit a particular profile. So this could be very wide. It could be that females are rejected because this is something which is predominantly male orientated. Or males could be rejected because it's predominantly female orientated. Or people of a certain age are excluded. How many people over 70 go surfing? Well, some might, but a lot may not. So therefore, purposive sampling is looking at the people who do go surfing, perhaps, and therefore people over 70 are rejected. Now that might be wrong. There might be a lot of people over 70 who go surfing, but purposive sampling would tend to suggest that those people are excluded. It starts with a purpose in mind, and the sample is thus selected to include people of interest and exclude those who do not suit the purpose. So it's looking at a particular purpose. It selects people who are interested in this purpose and excludes those who are not. The method is popular with newspapers and magazines which want to make a particular point. Newspapers and magazines might want to interview people of a certain opinion and then produce headlines based on those feedbacks which are sensational, and it appears that a lot of people believe it, but in fact it was based on a sample of people carefully selected who have a particular interest in some particular topic. It's also true for marketing researchers who are seeking support for their product. Sometimes the market researchers are not necessarily looking for objective criticism as well as positive comments. They're looking for perhaps people who support the product and who have got opinions about the product, who like the product but perhaps would like to make some recommendations as to how to further improve the product. That would be purposive sampling. It typically starts with people in the street, first approaching likely suspects, people who are going to cooperate and help, and then starting with questions that reject people who do not suit the profile. So it may stop people and say, do you buy a certain brand of washing up liquid? And if they say no, so thank you very much, that's the end of it. If they say yes, then they'll go, do you buy this brand or this brand or this brand? And they say they buy brand X, sorry, that's the end. If you buy brand Y, then it continues. So they are looking for people who have got certain characteristics and certain attributes and certain patterns of behavior. So it filters in this way. It's purposive. It's not probability, and hence it's subject to bias and to error. So there are problems associated with this type of sampling, and it means that although it's cheap and it's quite focused, the results may be misleading. Now let's turn to snowball sampling. Used when you have access to sufficient people with characteristics that you're seeking. So you're interested in people in the 25 to 35 year age gap and who are interested in playing football. Now the method, well, you find the people who in this category who are interested in playing football, and ask them if they would refer other people who fit your study requirements. Then follow up with these new people. So you find 10 people who are interested in football in the 25 to 35 years age group, interview them, and then you ask them, have they got any friends similar age who are also interested in football? And would they recommend you to their friends so you can go and interview them as well? So the method is repeated, asking their friends their attitudes and opinions about something about football, and then asking if they've got friends in the same age group who would be prepared to answer questions as well. So it's snowballing. The example could be, so for example, a researcher wishes to study old engineering skills, perhaps skills that go back 100 years. And he and she can only find, say, 2 retired workers who possess the skills. So having looked for people who did particular functions in industry using old engineering skills, they've only found 2 people. But during the interviews with these workers, they recommend 6 more contacts. The people being interviewed know 6 more who used to work with them. And these in turn recommend more workers with these skills. And in this way, the researcher may contact sufficient workers to complete the survey. Now, in this case, although it's very biased, it's a way of collecting information about former skills that have perhaps been lost. And these may be the last workers who have these skills. They have something in common. They all know each other because they've all shared this experience of working with these particular skills and they've kept in contact. And the researcher who found 2 at the start was in the end able to find many simply because they recommended others onto it. It's more of information gathering rather than sampling and extrapolation, but the snowballing technique was useful in that case. The snowball effect occurs when referrals multiply at each step. For example, if the researcher gets 2 referrals from each person, then starting from 2 people, you get to 4, 8, 16, and so on. So the snowball effect is, it grows very rapidly. But as I said, if it's used to make projections about the population, it is biased. And that is the problem. Snowball sampling is used extensively by salespeople. Customer referrals to new prospective customers are highly valued by salespeople. So if the salespeople sell you a particular product, and then ask you to recommend the shop to your friends, then that's a recommendation, and that's highly valued by the salespeople. The prospective customers have a relationship of trust and obligation with the referring customers. So the people who, the prospective customers, the ones further away, they have a relationship of trust and loyalty almost with the referring customers. So if a customer buys a television in a shop and then refers to their friends, refers the shop and recommends the shop to their friends who are prospective customers, the prospective customers are more likely to use that shop because they trust their friends. The relationship between the prospective customers and the referring customers makes it more likely that the new person will make a purchase. The referring customers who are trusted by the prospective customers further away, the prospective customers will now, based on the experience of their friends, go to that shop and make the purchase. It's snowball. One set of customers has referred to the other set of customers. So it's snowballing. Now the bias in snowballing. Well, the need to get a person to give a referral means that the researcher has to form a relationship with the person. So asking the person to refer to their friends normally means having some sort of friendship or relationship with the person being interviewed or the person being sampled. Otherwise, the person may not want to recommend their friends because they don't want to be seen to be making work or problems for their friends, having to deal with the interviewer and dealing with the survey. So it's only if the person being interviewed or being surveyed has a relationship with the researcher that this would occur. This can change the study results as effective biases in both the researcher and the target person develop. So it may be that the person being interviewed or surveyed starts to give answers that they think that the researcher wants, rather than the true answer. So when a relationship builds between the person being sampled and the researcher, problems arise. With care in selection and effort to avoid personal bias, snowball sampling, I should say, can still be a useful method. So even though there are situations where there's bias and there's likely to be bias with this method, it still can be useful. Respondents with certain characteristics may be difficult to find, as in the case of let's say the example I gave earlier, where workers had a particular engineering skill that was out of date and those skills were no longer required, but people wanted to find out about those workers from a historic point of view perhaps. Then snowballing is a valuable option in that case. Snowball sampling is also known as chain sampling, or chain referral sampling, or referral sampling. These are different names for snowball sampling. Finally, when the sampling is done and when the work has been done, any references that were used in the preparation of the sample and in the all of this data capture, sampling, literature and so on, when this has been done, has been completed, the references that were used should be collected. Normally they're presented alphabetically. They may be presented chronologically if it's the same name, or reverse chronological, as in the case I've got here, 97 before 2002. It should be the name of the person, the name of the article, the place of publication, or the journal name or the book name, the edition, in this case Social Problems 44 or Social Problems 49, and the page numbers. In the first one it's pages 174 to 199. So what we've looked at is different types of sampling: random sampling, probability sampling, and convenience sampling, snowball sampling, and non-probability sampling in general. This class overlaps significantly with other classes in this series of lectures and this series of videos. So it's important that you link this to the other videos to get a fuller picture. Each video, although it may cover the same substantive areas, is covered differently and gives a different perspective. So it's important to go across each of the videos and make your own notes from them. But that concludes this video, and that's all I'm going to do in this session. So thank you for watching.